The channel. I want to use this circuit to further explain nodal analysis. In case you have seen our previous lessons on nodal analysis, you can just pause this video and try your hand on this circuit. Else, if you have not seen our previous lessons, I'll advise you check the description below for our previous lessons. That said, let's get it. Now, here's the circuit. The first thing is to pick the node. It's a simple circuit, very simple circuit. There are two nodes. Here's node 1 and here's node 2. Obviously, we'll take node 2 here as our reference node with potential of 0, while we take node 1 as where we have our voltage V. Now, current will emanate from this cell, the cell of 4 volts, and from this other cell of 4 volts. Then we'll have both currents coming into this line. So that if I tag this I1, let me tag this I2, and let me tag this line I3. So that I'm saying that I1 plus I2 is equals to I3. In that case, we begin to define equations for both I1, I2, and I3. Now for I1, saying that 4 volts minus 2 I1 minus 3 I1 minus, now if you look at this battery or this cell, I'm going from the negative to the positive, so that becomes plus 2 volts is equals to the potential across this point is V is equals to V. Now, so that I have 4, I have 2. 4 plus 2 is 6 minus 5 I1 will be equals to V. So I can collect like times, and I'll be saying that my minus 5 I1 is equals to V minus 6. So that 5 I1 is equals to 6 minus V. Then we'll be saying that I1 will be equals to 6 minus V. So this V, 6 minus V over 5. Now for I3, let's define for I3. I3 is between V and the 2 ohms resistor. So we're saying that V is equals to 2I3. So that I3 automatically is equals to V over 2. Then lastly, we can begin to define for I2. Now for I2, I'll be saying my 4 minus 2 I2 minus V is equals to 0. So that 4 minus V is equals to 2 I2. I2 will equals to 4 minus V over 2. Now let's substitute for each of the currents in our equation 1. I'll be saying that I1 is 6 minus V over 5 plus I2 is 4 minus V over 2 is equals to I3, that's V over 2. To eliminate the denominations, let's multiply through by 10. So if I multiply this by 10, it becomes 12 minus 2V. 10 times 6 minus V over 5 becomes 12 minus 2V plus 4 times 10 divided by 2, that will be 5. Then the 5 times 4, that will be 20 minus 5V is equals to 5V. Now let's collect like terms so that my minus 2V minus 5V minus 5V be equals to minus 12 minus 20. Minus 2V minus 5V minus 5V, that amounts to minus 12V. Minus 12V is equals to minus 32. So my minus here cancels minus, so that V automatically will be equals to 32 over V. 32 over 12, 32 over 12. 4 in 12, that's 3. 4 in 32, that's 8. So that this is equals to 8 over 3 volts. 8 over 3 volts. Now, if V is 8 over 3 volts, we can begin to find each of the currents in each of the amps. Across my I1, we already know that my I1 is equals to 6 minus 5 minus V over 5. That's equals to 6 minus 8 over 3. 8 over 3 is the same thing as 2 whole number 2 over 3. That's 2.67 over 5. That will be the same thing as 2.67. 6 minus 2.67, that's 3.33 over 5. Now for I1 or I3, I3 is equals to V over 2. That will be equals to 8 over 3 times 1 over 2. 2 here is 1, 2 here is 4. That's the same thing as 4 over 3. That's in amps. I1 also is in amps. Then for I3, I can leave that with you to determine for I3. I'll be glad you share your results with us in the comment section. Thank you for staying with us and see you in our next class.